may have to calibrate here just because. Brianna Massey. El numero 3. We didn't do 3 yesterday? Let's take a quick peek. Oh yeah, some of my favorite problems in all the world on the form of number 3. Vertical yardstick casts a shadow 24 inches at the same time the flagpole casts a shadow 16 feet long. How tall is the flagpole? Pictures are us, yes? So you've got the vertical yardstick, which is 1 yard, and it casts a shadow 24 inches. Now, you're right here, you may want to stop with that and say, okay, a yard is how many inches, Brianna? You probably want these to be in the same units of measurement. So there would be a little hint I would have for myself, just because that's your, when you're doing these two together, they have to be the same. So there's that triangle. And the other one says, a flagpole casts a shadow 16 feet long. And here's your flagpole, it's a bigger triangle. This is 16 feet. Okay, you can keep this in feet, just knowing that when you get your answer, this will also be in feet, which is fine, because it entirely specifies one another. But you want to make your little ratio box here. And you've got the small triangle compared to the big triangle. And the two things you're comparing would be, you've got the shadow and you've got the height. I'm going to change this. So when you do that, the shadow on the small one was 24 inches. Shadow on the big one was 16 feet. The height of the small one was 36 inches. And you are looking for the height of the big one. And its answer will be in feet because that's what the top is there. So there's your little, whatever. 24 over 36 has to equal 16 over what number? Easiest way to do that, tie. Before I did that though, I would probably do something else just to make the numbers a little easier to work with. Yeah, 12 goes into both of those, so you divide them both by 12, you get 2/3. Now would you have to multiply across? No, you could just go, oh, this is times 8, and this times 8 gives you 24 feet. How about that? Does that work? Is that what the answer was? Flagpole is 24 feet tall. Is that a reasonable height for a flagpole? Probably. What was the other one? Like the 72 foot tall. That was unreasonable. That's a little bit. Riley?
5.
Number 5. The speedometer of Maury's car shows the speed in both miles per hour and kilometers per hour using 1.6 kilometers as the equivalent for 1 mile. Find the miles per hour rate that is equivalent to 80 kilometers per hour. A lot of words there. How would we start this out? I would write down this. What does this mean? 1.6 km equals 1 mile. That's why a 5 kilometer race is less than 5 miles. So basically, Riley, they are asking you to change 80 kilometers per hour, 80 kilometers per 1 hour. They want you to use this as a unit multiplier or a conversion fraction, if you will, and change it not into kilometers per hour, but make it into miles per hour. So in order to do that, you have to multiply by the fraction. Where does kilometers have to go? If it's on top here and you want it to cross off, it needs to go on the bottom. And what are we changing it into? Miles. And here's your, 1.6 goes with the kilometers, so it goes right here. And the miles is 1. So now your labeled kilometers cross off. You're left with miles per hour. You just have to do the math. And it is 80 over 1.6, or 80 divided by 1.6, which happens to be 800 divided by 16, which in fact is, I believe if you do the math, it'll be 50 miles per hour. Or you would say, why don't we as a country just go with kilometers all the time and never do anything in miles per hour? That's it.
Just send a presidential
You've
letter,
caught on to that, huh?
send a letter to the president. We want the metric system.
Donald Trump has more issues than kilometers per hour. Forging ahead to new and uncharted Lady Kavarik waters.
Number 17.
17. If I were taking notes on 17, I would write down to myself, if you have a fraction to a negative exponent, what do you do to make it a positive exponent, Lady Kavarik? Thank you for your brutal honesty. So you will know something today. What do we do to change that to a positive exponent, Keith? Yeah, it's a pretty simple thing. With fractions, all you have to do is flip it over. In other words, make this 2 over 3, and then it becomes to the positive 1 power. So you don't even have to worry about that. And anything to the first power is itself. So this really turns into 3/2 minus 2/3, which you probably want to write up and down. 3/2 minus 2/3, common denominator of 6. That times 2, that times 2 is 4/6, that times 3, that times 3 is 9/6. 9/6 minus 4/6 is 5/6. Again, remember, negative exponents have nothing to do with whether your answer is negative or positive, per se. In and of themselves, whatever that means, Carolyn.
Number 1.
Again, number 1. Number 1. Do $120 repair bill included $36 for parts and the rest for labor? What percent of the bill was for labor? Now please note that this is not an increase or a decrease in percent thing. You're not starting at 100% and moving things around. You are taking two things and combining them to get your 100%. So when you do your little percent table ratio box, you are having something plus something equals a 100%. And what two things are you adding together? Parts plus labor. This is your percent, this is the actual, gives you 100%. You don't know anything about the percents except that the final bill gives you the 100% for labor. Are you with me on that? You didn't try to do it as an increase or decrease in percent, did you? Filling in the blanks, then we know this. The $120 total bill included $36 for parts. And you can probably figure out what labor would be. What would labor be? 120 minus 36? Everybody, 84, right? Yeah. 84. And I am asking for what percent was labor. So this is the one I want right here. Percent labor. Don't need the 36 for my equation there. It's just going to be what number over 100 equals 84. I can do it like that, over 120. And again, I would try to reduce that fraction if at all possible. I'm sure something goes into it. 4, I know. What's that? 21 over 25? No, sorry. 21 over 30. Oh, and then I can reduce it again by 3, 7 over 10. And thank goodness, 10 times 10 is 100, so 7 times 10 is 70% was labor. I hope that's the answer I read. Was it? Yeah. It's always good when the teacher gets the problem. that clearing up monkey waters? Help me on, Lane. Did you really make the pancakes? That's what will happen when you eat all that bread and stuff, you get all tired out. Elijah Fisher.
What was the answer for number 6?
Somebody got the answer to 6. I don't have my answer in front of me anymore. Might as well do it since we're here. The length of a diagonal of a rectangle. There's my rectangle. The diagonal length was 24 inches. And, oh wait, what is the length? Sorry, it doesn't tell me that, does it? It wants to know the diagonal length of a rectangle that is 10 inches wide by 24. They want to know what that is. Again, hopefully you can recognize that if it's a rectangle, this is a right angle. So you got a right triangle there, Pythagorean theorem. Hopefully there's a 1024. Oh no. If there's not a 1024, you have to then look for what, Josh? Shrink that triangle down into some smaller ratio. What can I cut both of these by? 2. So that would make this little guy a 5 by 12. Is there a 512 one? The long side of a 512 is 13. Is my answer 13? No, because that's the ratio, the small triangle. What do I have to do to get the big one? Double it again, just like double 12, double 5, double that. 26 inches. Back when a 26-inch TV was a big screen TV. Now we're in the 70s and 80s. And they cost as much as Mitch!
20.
Number 20. Love number 20. Number 20 is just an equation. It's an addition equation, so you solve it by subtracting. I always think it's easier to think about, what would I do if there were no fractions there, Mitch? If it was 7x plus 3 equals 9. If you were asked to solve that equation, what would you do first?
You subtract 3.
Right. But I don't have a 3 there, I actually have a 3/4, so I subtract 3/4. I subtract 3/4 from 9/8, what is that? 6/8 from 9/8. And that gives me now 3/8, correct? And I have 7/8, x equals 3/8. I've done that. Now this is always that one where I told you a bazillion times. If at the end here you end up with a fraction in front of a letter, how do you get rid of that fraction? You, Isabel? How do I get rid of this fraction in front of the x? Wow, I'm a failure. How many people think they know the answer to this? Really? After all these times, I make a big deal of it every time I come up here and do this. I make a huge deal about it. How do you get rid of a fraction in front of a letter? Laney Kavarik, which is doing what? Elijah? Yes. You divide by 7/8, but when you divide, it means flipping and multiplying. 7/8 times 8/7, everything crosses off and it goes away, but I have to also multiply this by 8/7. And when you do that, the 8's cross cancel, you're left with just equaling 3/7. Anytime you have a fraction at the end, when you're solving an equation and it's in front of the x, you flip it over and multiply by it. Because that is division with fractions. Riley Harrington.
16.
Should we do 16 already? No. I love 16. Is it right there, that one there? Lots of ways to do 16. I think the way that I pretty much tell you is this. First thing I would do is get rid of my negative exponents by making them positive by doing what to them? Maddie, my What's that? Right, this is the only negative exponent, so I'm gonna get rid of this x to the negative 2, and I'm going to move it to the bottom and make it x to the positive 2. Now, once I've done that, I'm going to simplify, put together what I can on the top and the bottom, and then, wait, did I say move x to the top? What did I say? Somebody help me here. Anybody? Is that what you did? Alright, well, let's just go with that since nobody's got a suggestion. What happens when I put y and y together? You get y squared. What happens when I put x and x to the squared and another x squared is x to the 4th, and then I have a y there. Now, I'm still not done because things can cross off top and bottom. You think about this x to the 5th as being 5 x's, and this x to the bottom as being 4 x's. What's going to happen? 1 for 1 they will cross off. So 1x with another x, second x with a second x, third x with a third x, fourth x with a fourth x, and you're left with this 1x on top that doesn't have anybody to cross off with on the bottom. Same thing with the y. You have 2 y's on top and only 1 y on the bottom. That 1 y is going to cross off with one of the 2 y's and leave you with a y. And then I have this 6 over 2, which 2 goes into 6 3 times. Seems to me like I told you before to move all that stuff to the top. But it doesn't really matter how you do it. It's going to end up being this. Oh, they're mesmerized. Maybe too much syrup. What was carbohydrates? Just slow you right down. True.
7,
10,
just 7,
10,
just 7.
just 7. What did you get for an answer there, Drew?
Yeah, close to pointing to the left.
Close to who?
What?
You have to solve that for x, so to solve it, it's just like an equation. How do you solve that for x? You do the opposite of adding 2, which is subtracting 2. So x is less than 1. When you graph it at 1, is it an open circle or a closed circle? Why is it open? Because it's not equal to. It only gets closed when there's an equal sign under there. Means it starts at 1 but doesn't include 1. And it's any numbers that are less than 1, which means it goes this way. Again, a helpful little check on that is you see this less than sign looks just like the arrow of the side where it goes to. Ain't that pretty? It's down there, but it did not make any rhyme or reason. What's tomorrow? Country day? Wait, were we on that?
The concert starts at 10. There's one at 10:30.
No, there's one at 9 and 10. Where else are we at here? Our test will be whenever we have a nice long class period. Isabel?
Number 13.
It may have to be Thursday. I don't know. 13? Is that on this side over here? The way at the top? The way at the bottom? Number 13. Oh, this is a good one. I'm surprised more people didn't ask about this. Number 13 doesn't appear on your reference sheet, so that's one of those ones where you will have to figure it out. How do you do it? Again, there's a couple different ways you can think about this. First one, how do you change it to a percent? Keith?
Divide 5 by 12.
You could divide 5 by 12. Let's do that just for fun. 12 on the bottom is what gets divided into 5 on the top. you need to add decimals until you either get it to work out or repeat. 12 doesn't go into 5, it does go into 54 times, that's 48. Down, 12 goes into 20 once, that's 12. 12 goes into 80, what's that, 6 times? Which is 72, and you get an 8 again. So you know that you're going to keep getting 6s because you keep getting 80. So the decimal is 0.41, and the 6 repeats, so you put a line above that. Wait, was that your percent? That's our decimal. How in the world though do I get that to be a percent? Because generally speaking, we don't like to mix decimals with percents. Usually they like the percent to have a fraction in it as opposed to a decimal. So Brianna says, what's that? Multiply by who? Or actually, you can always multiply that by 100%. When you multiply by 100% though, you get this. But like I said, the book is not going to give the answer in decimal form with percent. You need it as a fraction. So what do? It's not 41. And by the way, it's not 41 6/10 either, because actually this is a repeating decimal. You can't really leave it like that. Somebody? Mitch?
41 2/3%.
How do you know that?
Because 0.6 repeater is same as 2/3.
It is 41 2/3%. Now you could have come over here, children, and done this. At the end of, after 2 places after the decimal, okay, you ended up with an 8. Well, instead of writing it as a decimal of 0.6, you could write this as 8/12, which is 2/3, 41 2/3%. If you know that 0.6 is 2/3, that's what you write there, but you can't write 6/10 because that's not what that is. That's a repeater 6, it's actually 6 whatever forever. So you just have to recognize whatever your decimal is. Or, check this out, you could have said this. You can always change something to a percent by multiplying it by 100%. Wake up, Jason. That means this. I can multiply this by 100%, put it over 1. Okay, I end up with 500 over 12. And if you divide that 500 over 12 out, you end up with that 48, 41 2/3. You don't have to deal with decimals at all. Always, always, always can multiply by 100%. There must be more out there. I'm almost tired of talking. No volumes, no nothings. Drew?
19.
We did 19 already, didn't we? Is that this one? Is that this one? And that this one? It's an equation, Drew. How am I going to solve that equation? How do I get the x by itself? Would it help, Drew, if I switched this around and said this was 0.2x plus 0.8 equals 1.2? What would you do there?
Subtract 0.2 from.
I don't. I don't get rid of the x term has to stay. The only way you split these up are by multiplying or dividing. This is the term. The term that doesn't have the x has to go away first. Whether it's here or here, it doesn't matter. I need to subtract the 0.8 first. Subtract the 0.8, you're left with 0.4. Now, once you get here, Drew, how do I solve it? Once I get to this point, when I subtract my 0.8, I'm left with 0.2x equals 0.4. How do I solve that? Really? What if it was this? 2x equals 4, how do I solve that? No idea? Raise price? Yeah, last step is always to divide by what's in front of the x. Divide by 0.2, divide by 0.2. What is 0.4 divided by 0.2? Move the decimal, move the decimal. I believe we just get a regular old 2. Last step, anytime you have that x left at the end of the number front, you divide by it. Here we divide it by, we divide by fractions with a multiple. I said that 3 times already today, just in case you forgot. That's what I think too. Teacher?
I like your die.
I thought that was really good compared to tomorrow. Are there more questions? Nobody has anything else? Which ones have we not done? Let's take a quick peek here. 18, 12, we talked about. No, we didn't talk
We
about.
did 12.
Yeah, we did on 11.
12 we did. 15 or 18 or 14. Volume just means you multiply all three there, Mitch.
I was gonna say number 7.
No, we
You
did
did
one.
Oh, we did?
Number 7.
7 was done.
9.
Drew asked that one. Number 9. Number 9. A coin is tossed and and the number cube is rolled. What's the probability of getting a heads and even number? When we talked about this, you're flipping a coin. Do this. Like that. And you're rolling a die or whatever this thing is. They want the probability of what 2 things happening, getting a heads and getting an even number. In order for 2 things to happen, it is the product of the probability of each of them happening. So you gotta take what's the probability of getting a head and multiply it by a probability of getting an even number. Well, what is the probability of getting a head? 1/2, 1 out of 2 times. And then you have to think about when you roll a die, your choices are 1, 2, 3, 4, 5, and 6. What is your probability of getting an even number? Well, how many? There's 6 different possibilities and 3 of them are even. So that's the same as 1/2. The probability of both of those happening is what you get when you multiply those 2 probabilities together. What's 1/2 times 1/2? 1, 4. 1 out of 4 times you should get a head with an even number. Mesmerized. Any more? Any less? I'm sure boys never have a pancake breakfast again. Nobody on, number 9.
Did we do number 4 yet?
We did number 4. Tax and tip are always multiplication. Write the equation of this line and slope intercept form. Everybody's good with that? These are incorrigible. Nobody struggles with scientific notation, multiplication, or we got 15 wrong because they didn't put 4 to the 0 power is 1. 3 to the first power is Josh.
How do you do
Number 18. I was hoping somebody would have. Watch how big this is.
Whoa.
Josh, the first thing you do is multiply the 2 left things. What is 4 times 3? And then you write down your times 10. And what do you do when you multiply this and that together? What? You don't get negative 12. When you multiply bases with exponents, you add their exponents together. What is a negative 4 and a negative 3 added together? Negative 7. But Mr. Hahn, I put that on my paper and I got it wrong. Why is this wrong so far? Why is that wrong, Aubrey?
because you can't have negative
Incorrect. You can't have negative exponents in scientific notation. The only time you're really allowed to have negative exponents is scientific notation, which this is. You got another suggestion? Poppy? No? Nothing?
The decimal?
Something about the decimal. Jenna D?
The number has to be between 10.
Yeah, this number has to be between 1 and 10. Oh, that's a shame. Okay, this number has to be between 1 and 10. So to get it to be between 1 and 10, Danny, what do I have to do?
Okay, put it down
Where?
between 1 and 2.
Where did it start? Here, right? I moved it one place, made this smaller by one place, so I have to balance that out by making this one bigger. And a negative 7 plus 1, price?
-6.
Negative 6. So my answer actually ends up being 1.2 times 10 to the negative 6th power. That's exciting. Based on the number of yawns, I assume that that was the last question there. Nobody had any other ones that are. What did I do to make this more exciting? I couldn't put it against. I could moonwalk. That is the end of